In this video, we're going to make a guess the number game. So the computer is going to pick a number, and we're going to guess between 0 and 9. So during the game, when the computer picks, let's say, the number 5, when I make a guess, it needs to tell me higher or lower until we win. So let's get started by creating a new level. At the very top File menu, we could click File and New Level. Let's also make it an empty level. Now let's create a widget blueprint. At the very bottom of your screen is the content browser. If you click on the content folder, you can see all the folders within your project. I have the Andy Blueprints folder that has all the examples and blueprints we've been doing. In that folder, I want to add a new blueprint. So I will use the Add New button and locate the User Interface category, and I'm going to choose Widget Blueprint. And how about we name it Minigame? We're using widgets because they give you a very nice user interface. You can use this to make menus in your game, a level select screen, a pause screen. You could use it for dialogue or like a shop screen where if your player goes up to something and starts interacting, or even another layer of gameplay like a turn-based battle. So let's open up our minigame so we can work on it. In the widget blueprint on the left side of your screen is the palette panel, and you can drag in things to your canvas like text or buttons. And just like pretty much everything else, you can select the items to see the details on the right side of the screen. So our mini game needs these buttons and texts, and you could even put the text on top of the button, increase the font size, and also color the font so that it's visible. And I'm going to mark it with the symbol for Shift 6. So that was the up button, and the down button will be pretty much the same, but I'm going to use the letter V. So there's other ways to make this interaction happen. On the left side, you could find the slider and use that if you like, so the player can choose between 0 and 9, as long as they're comfortable choosing and you can find the details for what you need. So I'm going to leave it with the buttons that we have here, and this is going to allow us to choose the number. That being said, let's drag another text field here into the canvas and put it next to our buttons. Let's say, for example, we chose 3. Let's also make this clear and visible, so I'm going to increase the size to make sure players can see it. And so we're going to build an interaction so that when we press these buttons, the number will change accordingly. Let's also adjust this text field as the title of our game, Random Number Game. Let's also not forget about our anchors, the first detail in any of these fields. So if my text is at the top of the screen, I want to anchor it to the top of the screen. And also for the rest of these, since they're at the bottom left corner, we want to anchor them to the bottom left corner. I can also choose the center of the screen to anchor it, but I'll just leave it here at the bottom left. Having these anchors makes it easier to know where to draw them. So this is for multiple screen sizes or resolutions. Alright, so what's next? Well, when I choose an answer, I can win or lose. So let's put a message here for that. As a text field, I will put it to the center of the screen and change the label so the player knows they won. Let's also remember to anchor it, so I am at the middle of the screen. Also, since the player doesn't win right away, this message needs to be hidden until we find the answer. So under the details, there's a visibility property that should be set to hidden by default. When we find out the player wins, we can change this value back in the code. Speaking of that, we need a button to check when we have the right answer. So from the palette panel, I'm going to drag in a button and place it here in our canvas. And let's also anchor it. I guess I could put the button behind the number, but I'll just leave it here on the side. So now we need another indicator here on the right side of the screen, which I'll drag in as text, so we can know if the player needs to choose higher or lower. And I can use the same symbol as I used for the buttons. Okay, so when I press this number in the game, the system should check our number for the solution and tell us if we need to go higher or lower. So by default, we can mark it as a question mark. Let's just make sure that the player can see it at all times. Oops, I keep forgetting my anchors. So since this question mark is on the right side of the screen, let's anchor it to the right side of the screen, and I'm going to double check the rest of these. Great, so now let's move on to the game interactions. At the top right of the screen is the graph, and you can find it with the button. And so in this blueprint graph, the first thing we want to do is get a random number from the game when it starts. So we can use the right mouse button to move the canvas around, and if I right click, I can find actions and functions. Searching by keyword, I want to find random integer in range, and I want a range between 0 and 9. So this random integer in range function will give us a number between the minimum and the maximum. On the left side here we have the inputs, and on the right side we have the outputs. So now we have a random number. But if we need to use this in the game, we should make it a variable. Well, since I know that this value is what I want as the variable, I can right-click and select Promote to Variable. This will create it for us, and all we have to do is name it. So I will name it Random Number. So I want to hook this in to the beginning of the game. So we connect the set to the construct event. So what this code is doing, these nodes in the visual script, is that when the game runs, we want to set a random number so we can use later. I don't know what it is yet because we're not playing. Okay, so that was pretty easy, right? Let's go back to the designer for the next interaction. Now that we have a random number, the player needs to make a guess. We're going to use these buttons here to provide those interactions. It doesn't really matter where we begin, so I'm going to choose this check button. If I select the button, I can scroll all the way down in the details to find the on-clicked event. So let's activate that event with the plus button. And so now the system gives me an event in the graph that we can mess with. So I could put any kind of response here for the click and any kind of flow I need. And so for our interaction, a few minutes ago we created a random number, and I can use that in the graph. So if I right click, I can find that item by name, get random number, and I want to check if it's equal to the player guess. So if I drag a connection from there, I can find equal. This will give me a Boolean result, letting us know if it's true or false. To check these results, we can use a branch. So I can use the hotkey B for branch and click in the graph. I can also right-click in the graph and search for it by name. And I want to connect it like so, with the condition to the equals. Because if this is true, we have won the game. But if not, we need to take another guess. So we're not finished just yet, because we have the code here checking for equals 0. But we don't want to always check 0, we want to check the player's guess in here. So where do we get that? Well, back in the graph, we have this text field to represent that. So I want to use that. Let's click on it and select it, then go to the details and change the name. Let's rename it to player guess, because this will be the guess that the player has. I'm also going to check on the property isVariable right next to the name. Doing this allows us to make the changes to the variable in the code. So let's go back to the graph so we can use this in our code. On the left side of the screen, we can see the variables there, or we can right-click in the graph to find them by name. Get player guess, because set player guess will change the value. Get will look at the variable type, so we can plug it into our number. But we can't just do that, right? Because the text is not the same as the integer type. So I'll drag a connection from the player guess object and find get text to retrieve that data. And this text data is still not the same as the integer type, so we need to convert it. So let's convert it with toString. This will turn it into a string which can be connected and converted for us. So with all these nodes connected, this will check if the answer is correct, which if it's true, we need to give them a message. What message was that? Let's go back to the designer. We have a uWin message right here. I'm going to select it and change the name. Let's rename it winMessage. I'm also going to check the isVariable portion next to it so we can modify this in the code. So let's go back to the graph, and now we can use this variable. So I can drag it in from the left side of the screen and choose get winMessage, and then drag from that and find set visibility and connect this action when the condition is true. So what about false? Let's go back to the designer. When the player makes the wrong choice, we have this indicator icon to let us know if it's higher or lower. So I'm going to select that indicator, and let's also change the name because the name doesn't mean anything right now. Let's rename it to result. Let's also activate the isVariable portion and go back to the code, where we drag in the results variable. And what do we want to do to the guess variable? Well, we need to change it by using setText, because if it's higher or lower, we can adjust the text here to match. I'm going to use the same symbols we used as the buttons, but you can use H for higher, L for lower, or any symbol you like. To check the random number, we can drag a connection from the random number and find greater than. And we can hook in the other value that the player guessed for that. So this return output is a Boolean, so we need another branch. So I can duplicate the one we have here, connect the conditions as needed, and also hook it in from the previous false branch. Because if the player did not guess correctly, we want to check if it's higher or not. If it is higher, this is true, and we can connect to the set portion that we have earlier to change it to a higher value. And lastly, when it's false, it's not higher, so it's lower, and I can use the same functionality from before, set text. Control W to duplicate, and hook in the connections as needed, with a different symbol for lower. Now let's compile and save. So now we need to work on these other buttons here when the player chooses up and down. So I'm going to click on the button up, and I'm going to rename it to button_up. Then I'm going to scroll down in the details looking for the events category to activate the onClicked. So when the player presses this up button, we need to take the guess that they have and increase it by 1. So let's right click in the graph and look for the option by name, player guess. We want to get player guess. And how do I change it? Well, if I drag a connection, I can find set text like we did before. So this new text value is going to depend on the old text value because it's going to go up by 1. And we did this before when we checked the player's guess by using get text and a couple of conversions. So I'm just going to duplicate those nodes that were missing and bring them down. So once we have those connections in place, we have the player's guess as an integer, and I want to take this number and increase it by 1. So let's find plus, or addition, leaving it as +1, and finally hooking this value into the set text. Don't forget to hook this into the button up pressed event. Alright, that takes care of button up, so let's go back to the designer for button down, and I'm going to click on that to rename it button down. And so for this behavior, we need to do pretty much the same thing as the button up. So I'm going to scroll down in the details, I'm going to find the on-clicked option to activate it, and in the graph, we want to do the same thing as button up, but it has to be -1 instead. So I can drag a bounding box around all my nodes, so I can right click on them and select duplicate. This will make it a lot faster to work with. Hook this connection into the button down, and then make my adjustments. The only adjustment I need to make is change +1 to -1. You can say +-1, but that looks a little weird, so I'm just going to leave it as subtraction. So now with more gameplay in this script, the script is looking kind of messy. So I can drag a bounding box around my nodes and press C for comment. This could leave a little note here to briefly explain what's going on. This makes it a little bit cleaner and nicer so I can organize it around as I want. So great. Did we forget anything here? I'm going to compile and save just to double check. Looks like we got no errors. So far so good. So why don't we test the game? First I'm going to dock the tabs here so we can go back and forth between the minigame and the level. And if I hit play, nothing seems to be happening, right? That's because we never put this screen widget on the player character. Well, in the top toolbar there's a blueprints button, and we can navigate down to open level blueprint, because every level comes with a blueprint. And if we find the begin play event when the level starts, we can do that by dragging a connection and finding create widget. So this is a built-in function to create and construct that widget, and it has parameters on the left side of the screen, inputs that we need to put in. So I'm going to select the minigame, and for the owning player we can drag a connection and find get player controller. Player 0 is the first player, and we're in a single player game anyway. So this function also has a return value, which is the widget. If I drag a connection from that, I can find add to viewport. This function is context sensitive because it only lives in the widgets, so I have to drag from that blue value to find those functions. If I right click in the graph and look for add to viewport, there is no context, so it doesn't know where the function is. So this minigame we have requires the player to use the mouse as input. So if I drag a connection from the get player controller, I can find set show mouse cursor to have the cursor enabled on screen. Just make sure to connect it in your logic chain and activate the property. Great, so let's compile and save to check our work. And it looks like I never saved this map, so let's do that. I'm going to go to the maps folder and rename this to something like mini game random. So now back in the level, I can actually play the game and see what this mini game looks like. So since this has been constructed, there's actually a random number that the computer has chosen, and I can start making guesses as a player. Let's say I choose the number 3. So I'll check that, and it's telling me that it's a higher number than 3. So I need to make another guess. How about 4? Check is still telling me that it's higher, so it's still higher than 4. I don't know, how about 7? 7 is too high. Maybe 5? There it is. Okay, so that's working. But when I play the game, this feels a little bit boring, right? There's not enough pizzazz here to let me know what to do. There should be a message here that tells the player to make a random guess. So let's do that. If I stop playing and return to the minigame widget, I can add another text here, make it large enough, and put a message. So I'm going to place this message in the center of the screen here, and remember to anchor it to the closest anchor point. If yours is in the bottom or the top, make sure the anchor is accordingly. You can also put the text directly on the win message, because the win message will not be displayed until the player wins. So you can have elements on top of each other just as long as you control when they're being seen on the screen. So the player should always be able to read what message they have. Okay, let's also change the name of this text to question. We're also going to check the isVariable option next to the name so we can manipulate this in the code. That being said, let's go back to the graph. So there's a couple of ways to switch the visibility of our message, and we can do it in the begin play, the construct, when this item gets created, or we can do it when a user presses any of these buttons. So let's get the reference to the question by either dragging it in or right-clicking and finding it by name, get question, and drag a connection from that to find set visibility. We want to change the visible property to hidden. This will hide the element. And we want to hide this message when the game starts. So in the construct event, we can hook in a delay node to wait a few seconds and then connect to the set visibility to hide it. And that's one way of hiding the message for the player, so you can play test and see if that works for you. But if not, we can do it another way. So I'll remove that connection here, and let's put it when the player makes any choice in the game. So I can move the nodes over here and hook them into place. I can also hook in the other ones for the other button presses, but this looks like spaghetti, so I'm going to duplicate the nodes and just move it over. This makes it a little bit cleaner to see, and it does the same thing because it sets the property to hidden. Let's not forget when the user checks their answer. When the user checks their answer, we can also put this notification away. But this one's a little bit tricky here because we have 3 spots that we split the connections with, so I would have to connect it 3 times. Or I can insert this in the front, so that way we set the visibility and hide the message as soon as they press the button, and then continue off with what we were doing before. Okay, so let's compile and save to see if we have any errors, and we can play the game. So it gives me the message, can you guess what number I'm thinking of? And as soon as the player makes any decision, the message goes away, and we're notified with the next move. So you may have noticed that when we play the game, you can actually put an option for negative numbers. Let's fix that. So in the minigame, when I go to one of these buttons, let's say when I press down, what does this do in the graph? With the button selected, I can scroll down in the details panel to find the event we have activated. So for that logic, we have the number being subtracted, but we just force it to that value. So let's change that by doing something to the value just before we pass into it. So if I drag a connection, I can find clamp. Clamp is a math function that will take the value and force it in between a minimum and a maximum. The minimum I want is 0, and the maximum is 9. You can change this later if your game has higher numbers. So let's take that value and insert it into the new value for the text. So this was the fix for the down button. Let's do the same for the up button by right-clicking and selecting copy on the clamp. Now let's find the logic for the up button so we could modify that one too, because when we press up, chances are the number could go higher than our maximum. So let's do the same thing there. Let's insert the clamp node. If I right-click in the graph, I can scroll all the way down to find paste. The hotkey is Control V. And I can insert this into the logic chain. So I want to take the value that we have, and before we pass in the new value, I want to make sure I clamp it between the minimum and maximum numbers. Let's compile and save. And now when I play the game, the lowest number I can choose is 0. The highest number I can choose is 9. and it will stay that way forced and clamped no matter how many times I spam the buttons. Okay, so now when we win the game, somewhere over here in the code when we check the player's guess, we can load a new level. So let's drag a connection in the winning logic and find execute console command. And so we want this console command to change the level, so we can type in a command open, space, and your level name. My level name was minigame random, so make sure you spell yours correctly as is, because it finds it by name. So this will open the level right away, but we don't want to do that. We want to insert a delay in between these nodes to give the player some time to celebrate their victory. So drag a connection and insert a delay just before the console command for about 7 seconds. That should give enough time. This is the perfect time to add some extra celebratory effects like winning music or particles. You can add some fireworks here by simply adding an image with a color of red, green, blue, or a fireworks texture. You can animate it rising, and when it reaches the top point, you can add more particles, or you can set the visibility of other pictures and have them drop to simulate fireworks. So that gives us all the time we have for today. Thank you for coming. We'll see you next time.